Welcome to solverfy.
Hi. For the A part of the question, to estimate the mass of the Mount Everest, we can use the concept of gravitational attraction between the mountain and the plumb bob. We will assume that Mount Everest has the shape of a cone and its density is relatively uniform. The gravitational force acting on the plumb ball due to the mountain is given by F is equal to G into M of plumb multiplied by M of mountain divided by R square, where F is the gravitational force, G is the gravitational constant, which is approximately 6.674 into 10 raised to minus 11. M plumb is the mass of the plumb ball, M mountain is the mass of the Mount Everest, R is the radius or the distance between the plumb ball and the center of the Mount Everest. Now let's make some approximations and assumptions. First, we will consider the plumb bob to have a mass of about 0.1 kilogram and the radius of the earth is 6371 kilometers. Third, height of the Mount Everest as h is equal to 8848 meters. Fourth, we will assume that the Mount Everest is a cone, so the volume is 1 by 3 pi r square h. And fifth, the density of the Mount Everest is uniform. First, we need to calculate the volume and mass of the Mount Everest. That is, volume is equal to 1 by 3 pi into 4200 squared into 8848, which is equal to 5.96 into 10 raised to 11 meter cube. Now to estimate the mass, we need to multiply the volume by the assumed density. That is, M of mountain is equal to density into volume. Now we need to find the value of rho, which is the density of the Mount Everest. A typical density value for rocks and the minerals around us 2700 kilograms per meter cube. So 2700 into 5.96 multiplied by 10 raised to 11, which is equal to 1.61 into 10 raised to 15 kilogram. Now we can calculate the gravitational force. F is equal to 6.674 into 10 raised to minus 11 multiplied by 0.1 into 1.61 into 10 raised to 15 divided by 5000 square, which is equal to 5.35 into 10 raised to 11 Newton. Now this is the gravitational force acting on the plumb ball due to the Mount Everest. Now we can use this formula to estimate the angle theta by setting it to the tension of the plumb ball's string. That is, F is equal to mass of plumb ball multiplied by G sin theta. That is, sin theta is equal to F by mass of plumb ball multiplied by G, or theta is equal to sine inverse of 5.35 into 10 raised to 11 multiplied by 0.1 into 9.81, which is equal to 89.99 degree, or approximated to 90 degree. Now for the B part of the question, we have calculated the angle theta, the angle that is approximately 90 degrees, which means that plumb ball is hanging vertically when it is 5 km from the center of the Mount Everest. This is because gravitational force from the Mount Everest is pulling the plumb ball vertically towards the mountain. I hope the solution is clear.